second part of the data mining. If you may recall to the KDD process, yeah. If you may recall to the KDD process, we have firstly in terms of data integration and also selection, where your data might come from multiple databases, yeah. And then after we have the data, we will look at the data itself, whether it contains errors and so forth. That is what we have done last week, looking at the pre-processing methods. Okay, so what are the main pre-processing methods? The main task. Ingat tak apa dia? Main task of pre-processing methods. We start with DC, data cleaning, and then we have DI, data integration, and then what else? What else?
Data transformation.
Yes, data transformation, DT, and lastly would be the data
reduction.
Okay, reduction. And then if you remember, in terms of doing the cleaning, we have some kind of missing value. We have using binning for smoothing the content or removing the noise. Okay, and then we can use some kind of other formulation like clustering and also linear regression to remove the missing value, and we can replace the missing value with min or mod. Okay, and then if you remember in the integration means that we are integrating the data by looking at the primary key, or we might integrate and reduce also remove the redundancy, considered as the integration. If you look at the transformation, okay, like you're implementing the binning methods, you are implementing discretization. The binning is also known as discretization. What will be other methods for the data transformation?
Normalization.
Yes, good. So you normalize the data into certain, or map the so-called value into certain range, yeah, using formula, yeah. So normally we have three methods, which is min, max, z-square, and z-score min mapping, and other would be the decimal, yeah. And then another part will be you might using the hierarchical, or you somehow would use discretization as well for the transformation. Okay, or sometimes if you involve numeric value, you might use certain like images. You would transform into certain value that involve new representation of the image. Okay, and then lastly on the data reduction, yeah, data reduction, if you can recall, yeah, is actually reducing the data into certain size, yeah. It's normally involve reduction of the samples and also reduction of the attributes. If you look at the attributes, you might aggregate certain attributes into another amount, like what you have number of sales, you can reduce into reduce into one new value, which is a summarization of the sales. And then you could use what we call attribute selection. Attribute selection would be choosing the most significant attributes, so you can reduce the columns or the attributes. How about the instances? How you can reduce these instances? The records. How about the instances? Apakah methods? What is the methods that can be applied in under data reduction? Filter, almost right, but what does it mean by filtering? Ataupun what will be the best words to represent filtering? If you may recall, this started from S. What is S? S. What will be? S is Sam. It is referring to what? Any idea? Sampling. So sampling, there are three main methods, three main techniques under sampling. You would go for the sampling with replacement, sampling without replacement, and also stratified sampling. Okay, so this is also under reduction. So reduction, mainly you have reducing the attributes or reducing the samples. Other than that, you might go for the compression just now, or you might go for the methods of apa nama tadi, hierarchical also can be also implement on the reduction. So today, if you look at the KDD, that will be the pre-processing, and then second part will be the 1, 2, and then the third phase will be on the modeling. So today we are going to start with the modeling part. So the modeling part will be very crucial. Data mining, pre-processing is a crucial, is a essential task, and then modeling also a crucial task. What we are going to look at today will be the first methods in the modeling, known as classification. Okay, have you gone through the video?
Yes.
All right, good. So classification will be very, very considered as a main what we call very clear definition is about to categorize, and then to put into different levels or label different groups of objects. So you have a set of data containing objects, and you want to put it into whether it's in category A or category B. So there is classification. Okay, and also under the classification would be related to what we call supervised methods. So what would be the supervised methods? If you look at this slide, can you see the slides? You nampak?
Boleh.
Yeah. So if you look at these slides, right. Okay, if you look at this slide, so the important, there is important terms given here, which is training and also test. And training data set, training set is actually involve records, content of records with attributes, and the attribute must be consistent, same, and the last attribute must be the class or the target of the outcome that you want to showing the category of the data. Okay, and what classification is actually to find a model to that could be defined as a function to differentiate these objects in the data. Okay, and the collection of records also would have some kind of actually this data will be split into two sets, which is training and also test set, and this test set will be used for the accuracy. Okay, so if you look at the illustration, so this is basically one particular data set. It could be from a big data, okay, data set or database. Okay, this is database. Okay, and then from database we will have some of the data being assigned as a training set, and some of data will be assigned as test set. If you look at the training set, will be majority of the records will be set as the training. Okay, so what the task of the training set is actually to let the algorithms, whatever algorithms that you use to learn about the data. Okay, and then the algorithms will will produce some kind of patterns, or will produce some kind of knowledge, and also, it could be something that formula, it can be represented as formula that might not be understood by yourself. Because it's a formula, how could you understand about that? But what you would gain later on is about the knowledge of classifying this object. Okay, so once you have trained, once you have trained the data, you would need to know what would be the performance of the model that you have developed. Okay, so in that case, this model that you have developed will be applied to the smaller size of data set. So at the beginning, all the class label here will be removed, and we will apply the model here, to predict the class label. Okay, so it was like your process of learning. It was like your process of learning. You can imagine that yourself, you are given some kind of objects to identify the shapes, right? So you are gathering this information or understanding the information by repetitively given by the examples. Okay, so it comes that is where the functions of the records. Okay, and then at the end, and the concept of training or the concept of understanding the patterns is by given the answers already. Okay, so you have this certain attributes, okay, for each record, and the answer is like this. Okay, if you have another type of this set of attributes, the answer will be like this. At the end, the model will learn about that. Okay, and partially from the data set here, will be set of attributes also, the same set of attributes and without the class, and then we ask the model to guess what would be the category or the label for each data. Okay, so let's say if you look at the actual results of the data, probably this one is yes. Okay, and then let me write here. Okay, 11 is yes, 12 is yes, this is and then we have 13 is no. Okay, and then 14 is no, and 15 is yes. Okay, this is the actual. Okay, all right. Okay, says that if you look at this one, and I create another column, this is actual. Okay, I create another column. This is the result of guessing, how the model guess. Yes and no, no. Okay, and this is yes, and this is also yes. Okay, do you able to think how actually you can determine the accuracy of this model? Do you have any idea? So this is actual, okay, and this part is predicted. The second column is predicted. Any idea? Boleh ke?
We check how many the model got it right and how many it got it wrong.
Okay, right. So that will be good answers. So how to how do you know about this? How do you get the accuracy for this these results? So here you can see, okay, this is right, 1, okay, and then this is also what, right, 2, this is wrong lah, okay, and this is right. So 3 out of 5, 3 out of 5, and then you times 100. So you will get the accuracy of the model, for this testing phase. Okay, boleh faham?
Boleh.
Alright. So this will be the main concept in under classification. Under classification, which you should understand that your database will be, or your source of data here, will be used to learn, for the model to learn on the patterns. Okay. Let's see. Okay, so that's what shows, that's what shows the difference, that also you need to relate to the difference of supervised and also unsupervised. If you look at supervised, it has the label given to the model or to the algorithm, so that the algorithm can observe this, so-called these patterns, and capture these patterns as knowledge to classify or to categorize the objects. Okay, meanwhile, if you look at the second here, the second types of learning is known as unsupervised, which is actually where the data is not given the class label. Okay, right, so that will be the major difference between supervised and unsupervised, and how it does the categorization will be discussed later on the clustering methods. Okay, so actually if you look at the image, obviously, those who learn with teacher is actually a supervised methods. But if you look at unsupervised method, it does not care about what the teacher says or what how the trainers inform about the data. The importance is that how this algorithm gain its side of the data. Right, okay, so this example of, I think this one can be, you can have a look at it later on by yourself, which is actually depending on the attribute type. Okay, so we have continuous, which is, this is actually numeric, and then this will be some of the algorithms that can be used for supervised, and this will be unsupervised. And when we have nominal or categorical, so this will be the example of algorithms can be used. Okay, refresh. This is recall je lah. This is the recall, how you can relate samples of tasks, for the example of classification tasks. Very predicting tumor cells. So this normally been done through looking at the images. Okay, how about the second one? Can you think what will be attributes involved in the credit card transaction? Any idea? What are the attributes for this part?
Types of purchases.
Types of purchases. You can look at the gender of the profile. You can look at what else? Apa lagi? Apa lagi? You can look at the time of payment, kan? You can look at the amount of the payment. That will be attributes of the credit card transactions. So from this we can, if we have lots of data, we can actually form some kind of categorization knowledge for the legitimate or fraudulence. Okay, the rest also some of other example, and if you look at the categorizing news stories, okay, this would be very interesting, because nowadays tasks will be very useful, because we have lots of documents, digital documents. Okay, right. Okay, so what we are going to cover in this subject, we are going to focus on decision tree. We are not going to look at all this lah. Okay, so definitely you already have done in this subject, in your own subject, Bayesian, and this one always should be have done in knowledge base also. Actually, there are many more. Okay, definitely, if you can see the algorithm. Okay, I'm not going to again repeat this part, because the processes will be very clear, showing the process will be involve what we call model development. Okay, and then the other part will be looking at the prediction of the classification. Means once you have developed the model, you could use the model to make a prediction. Make prediction of what? Making prediction of the categorization or grouping or what we call types of labels. Okay, right, so the important parts will be when you want to develop the model, make sure that each of the records would have the same size of attributes. Yeah. Okay, and why we are going to have a decision tree in this subject? Because decision tree is quite a robust methods, and it's provide what we call interpretability. Yeah, it able to produce what you see in the form of tree. And what is the advantage of the tree? What will be the advantage? Why we can, what will be the benefit from the tree? Any idea?
Easy to see options.
Okay, so you can visualize, you can see in the form of visualization, and this visualization providing branches until the leaf, which is presenting the outcome or the target, and this actually can be portrayed, can be actually presented as the if then rules. Okay, so remember that when you deal with knowledge base, three would be if then rules would be very, very important, because this is determining the conditions and also the antecedents, the outcome of the decision. Okay, so this actually this part is already been discussed. Okay, right. So this, if you look at this illustration again, it's been is showing how we use the data, and this data will be very structured. Remember, when you want to deal with modeling or any data mining task, make sure your data in the consistent way, or is presented in the standard, like marital status, you should have single, married. Okay, so like this one, suddenly you probably see something like that, oops, okay, without n. Okay, so this is error. Okay, so it should be it should be corrected. Okay, right, so back to here. Okay, so this is your training data. Training data must be very, very clean, and it could be the best is that to get the ideal distribution. Means that if you look at the refund, okay, so if you look at the marital status, taxable income, and so forth, so the value must be in the consistent, in that 50% is refund and 50% yes, and refund also no. Okay, 50% is balanced now. Okay, and then marital status, we have same value for a same count for single, married, and also divorce, for example. Okay, and then taxable, so taxable is a numeric, so numeric will be represented as a bell, bell representation, where the mean, max will be lower compared to the mod, and also the average. Okay, and what you have produced here, if you look at via the decision tree algorithms. Okay, so what you could have, will be the rules. Okay, and this will be the second phase, which you are using. You are going not using. You have another test data, test data that you are going to use to determine the accuracy. Okay. Okay, let me skip to this one. Okay, so this one will be example of decision tree. If you look at this, why we have example of decision tree. Let's have a look at this one. Okay, what you see from this tree and this tree, boleh recall tak? Okay, sekali lagi saya tunjuk yang ini. Okay, boleh capture this one. Okay, this one. Any difference?
The root node is different.
Yeah, good. Yeah, so if you see that this one is marital status, and this one is a refund. Betul tak? Okay. And definitely will be why happen like this? Okay, because of actually when you look at decision tree algorithms, yeah, there will be a lots of formula can be implemented in the decision tree. Okay, so decision tree itself is actually a big, yeah, a lots of techniques can be applied in terms of selecting the best, because the algorithms is actually the greedy approach. Greedy approach is trying to find the best attributes that can split the data into the same category. So you have to bear in mind what is decision tree algorithm. Decision tree algorithms is a greedy approach. What is greedy approach? Greedy approach means that it's trying to find splitting point from the data set, so that the data will belongs to the same category. Okay, how does it do that? Okay, right. So let's have a look at this data. Yeah, let's have a look at this this method. This model. Yeah. So after you have developed the model, how you are going to use? How are you going to use the model? Okay. So you have the model here. Okay, model given here, and this is a new data, and you want to predict or classify whether this person is cheating or not. So let's have a look at the value of the record. Firstly, for the refund. Okay, if the refund, refund equal to no, okay, so it will go here, okay, and check there is the value is equal to no, so it will go to this root. Okay, and then let's have a look at the marital status. Marital status equal to married, so it goes to this root. Okay, and then let's see let's see, you have another attributes, but if you look at the model already can decide, yeah, based on these attributes, yeah, the sample can be categorized into no. Okay, so the algorithm will assign the records into cheat, no. Okay, so this is very easy. I mean, normally, okay, we would have a list of rules, okay, so that we can identify which rules will be matched or will be fired, yeah, based on the given information or given data, yeah, given attributes, yeah, value for the records. Okay, so that will be how you are implementing the model. Yeah, this is clear, right? This is quite clear, isn't it? Betul tak? This part is quite clear, isn't it?
Clear, madam.
Okay. So I hope there is no question. So this will be the idea of what is decision tree, and also the concept of training and testing and how to use the model. Okay, so now we are going to look at the algorithm itself. Just now, like I said, that we are talking about decision tree, and why we want to use decision tree. Okay, and we in this subject we want to introduce you with what we call as the greedy approach. Yeah, right. Oh, ada yang bertanya ke? Sorry, saya tak perasan. Okay, oh, Majid menjawab. Alright, thank you. Okay. Okay, let's see for this one. Okay. Let me bring kejap, saya bring Teams ni kejap. Right. Okay. Right, can you see the next slide, this one?
Yes.
Okay,
Yes.
so now, yeah, we are going to look at the techniques in detail. Yeah, so we are going to understand further on how algorithms works. Yeah, Okay, so the algorithm is actually introduced by J. Ross Quillen, yeah, and is it known by ID3, yeah, ID3 dichotomizer, yeah, dichotomizer. Okay, at first it is ID3, and there is some other expansion of the algorithm which is known as C4.5 and also CART. And CART is actually a regression methods, yeah, right? And C45 is actually implementing what we call information gain, okay? And what we have in WEKA, some of you have done it, okay? What we have in WEKA is J48. Okay, why JA48? Because C is using C language and WEKA is using Java. Okay, and then yes, 3 is induction, learning the learning process through the class level. Okay. Right, so what we have in the 3 is actually a flow chart, means that it started from the root, okay, and then you will have intermediate nodes, yeah, in between, okay, in between, and at the end you will have the leaf, yeah, at the end you will have leaf, which is actually reflecting to the class level. Okay, so again, I repeat, if you look at the tree, what is actually a tree? Yeah, tree will be represented by the set of attributes in the data set. Okay, which attributes? Okay, so it starts from the root node. Okay, and you will have intermediate nodes. Okay, and these nodes is actually the independence attributes, or the what we call input. Okay, and it has branch. Okay, so branch will be presented the value of the attributes. Okay, so each node will be different. Yeah, each node will be different attributes. Instead, if you look at first attribute could be marital status, and lower level attributes could be refund. Okay, so it will be belongs to the different attributes, and branch will be determined by the value of the attributes. Okay, and lastly, you should notice that there will be leaf. What is leaf? It is end node. Yeah, it is an end node. There is no more branches below there. Okay, and this leaf will be presenting what we call the class label. If you have class label equal to yes and no, so you could see the value in the class label, in the leaf, whether it's yes or whether it's no. Okay, so the important parts here, yeah. Tree will be tree will be presented root, yeah, definitely a topmost node, which is the root node. Okay, and as I mentioned just now, tree is a greedy algorithm. Yeah? Greedy algorithm is applying what we call a divide and conquer. What does the meaning with divide and conquer? Okay, so divide and conquer in the context of classification, it means that it's trying to divide the data set so that the records will belong to the same class level for one particular branch. Yeah, and at the end you would achieve the outcome or the target, yeah, the targets, yeah, whether it is belong to class A or is belong to class B. So this is will be the meaning of divide and conquer in the context of classification. Okay, so it will start with the looking at the examples, yeah. All training at the beginning, it will look at the data set, and this data set will belongs to the root. Okay, and if there is if this data set has input attributes, yeah, with category, yeah, with categorical data, it will be processed further. If not, yeah, this if not, maksudnya if the data is actually presented or the attribute is presented in numeric, it will be transformed into nominal, which is true discretization, true meaning, and so forth. Okay, understand? Okay, so based on the categorical value just now, yeah, the data set again will be partitions, yeah. How it be partitioned? By looking at how it been created based on the values of each attributes. Okay, but here is the tricky one. Okay, how to determine when you have 5 attributes, which one becomes the topmost and which one becoming the second level, third level, and so forth. For that case, we are going to apply what we call a measure, a statistical measure, to determine which will be the most significant splitting attributes. Yeah, and I'm going to introduce you with what we have here. Yeah, information gain. Okay, so far, do you understand the concept of decision tree? Boleh faham tak?
Boleh, madam.
Boleh, madam, boleh.
Right?
I think so.
Okay. Yeah, so I think so. Okay, all right. So, and okay, so this is a recursive. Yeah, this is a recursive, means that it will goes through the records. Yeah, and then looking at the records. Okay, and then when it will terminate the process. When it will be terminating the process, definitely, as if you understand the concept, yeah, the first condition will be if all samples belongs to the same, yeah, same class, yeah, it will terminate the process and end the node with the label. Okay, and then other than that, if they look at the samples itself, the data set itself, there are no other samples need to be processed, so the process will be terminated. Okay, and also same goes to the attributes lah, definitely. There are no more attributes to be considered for the partitioning. Means that all attributes has been used and has been shown in the decision tree. Okay. So as we have looked at before, some of the history of the algorithms. So there are so many algorithms actually, yeah, in the beginning and currently, if you look at, there are lots of algorithms. Okay, but today let's have a look at the decision tree, Hans algorithms. Okay, so the Hans algorithms is actually basic of the ID tree, a basic for the C40F card and also J48 and so forth. Okay, the process is very clear, like what I said just now. Okay, first is we'll look at the tuples or the data set. If the records belongs to the same class, the algorithm will create a termination nodes, or what we call as the leaf. Okay, but if the records belong to more than one class, it will need to perform what we call as the attribute test. Okay, meaning that the algorithm will look at the attributes, the input attributes. Okay, which attributes can split the data into same class level the most. Okay, so yang mana satu yang akan menghasilkan partition? Okay, which attribute antara 5, for example, within these 5 attributes can split the data into the class level at the most, yeah, at the best measured, yeah. Okay, and it will apply is will repeat until there are no more samples to consider, or there are no more attributes to be considered. Okay, so all, as I mentioned, all all samples has to be taken into consideration in forming the data, forming the tree, or from all attribute has been considered in forming the tree. Okay, aggressive approach. Okay, let us look at an example. Okay, so given you to this data set, yeah, given you to this data set. Okay, imagine that all will be belongs to clear class cheat equal to no. Okay, so imagine first, yeah, first initial value will be all belong to cheat no. Is it true towards in the data set? Is it true? Adakah semua belongs? You have yes here, isn't it? And you also have yes here. And you also have yes. Betul tak? So it's not right. It's not right. If it's not right, then we have to look at the attributes. How many attributes that we have here? We have 1, 2, 3. Okay. So imagine that, we do not perform any calculation yet. Okay, this is just directly apply. Okay, this is directly apply. Okay, imagine that the algorithm already chosen, yeah, and look at and identify refund as the root, yeah. So what happened? Okay, so what happened? Okay, you can start with drawing, yeah. Ya, ada kertas tak? Kalau ada kertas boleh draw. So you can start with drawing here a root, okay, and this is actually refund. Boleh? Boleh nampak? Okay, so what is the value of refund? What are the values of refund?
Yes.
Okay, so kita buat branch begini. Boleh buat? Yes and no. Okay, now let's see at the value of refund equal to yes. 1, 2, 3. Boleh follow? Boleh follow? Okay.
Boleh.
And check pula the class level for refund equal to yes. What do you see? All no. So apa kita nak buat? Remember the process, if is all belong to the same class level, then you will create what we call, apa dia nama dia? Leaf node. So then the leaf node is belongs to the value of the class level, which is cheat equal to no. Okay. Root ataupun intermediate node adalah bulat, bulat ataupun oval, Kalau you tengok dalam WK is an oval, okay. And then here the the end node ataupun the leaf node adalah rectangle. Okay, how about refund equal to no? 1, 2, 3, 4, 5, 6, 7. If you look at refund equal to no, you will have cheat equal to no, cheat equal to no, yeah, and then yes. Says cheat equal to yes, and then cheat equal to no. Does it belong to the same class level?
No.
So what you have to do? Bukan make another branch. Sebelum make another branch, apa maksudnya? You have to choose, right? Betul. You have to choose another attributes as a splitting attributes. So imagine that we choose marital status. Okay. So you create a new node here as a marital status. And if you look at marital status, yang ni tadi kita remove dah, kita tak nak tengok dah because it's already classified. Yeah. Okay. So we are going to look, the remaining data set. Yeah. And if you look at marital status, we have married, and then we have merit, and then we have merit. Okay, imagine this is a binary tree. Okay, binary tree means that your branch will be with two values. So merit considered as merit lah, and then single and divorcee considered in one category. Okay, so look at merit. Does it belong to the same class level for cheat?
Yes.
Okay, so you can draw another branch here, and the value is merit. Okay, and what is the class level?
Cheat.
Cheat. All right, good. Cheat equal to no. Okay, so then the other one is, which is single and the divorcee. Okay, if you look at single and divorcee, single equal to no. Okay, single equal to no, and divorce equal to yes. Okay, and then we have single equal to yes, single equal to no. So it does not belong to the same class level, isn't it? So what we have to do next?
Branch.
So we find another splitting attributes, which is the next splitting attribute will be the taxable income. Understand? Boleh? So we already use merit this one. We already use merit also. Okay, so ini also dah guna. So we how many more records that you need to use or to classify? You already okay, ada 4 yeah, 1 2 3 4. Okay, 1 2 3 4. So how does it done? Because this is numeric, isn't it? Taxable income is the numeric. So remember just now, when it is a numeric, the attributes need to be discretized ataupun kena buat begitu. So it should have a two value. Okay, if you look at class level equal to no, class level equal those that is more than 80k, less than 80k. So this is less begini kan, 80k is equal to no. Okay, more than 80k will be equal to cheat equal to yes. So this is will be the tree. Understand? This is how the algorithm create the tree by looking at the data set. Okay. Firstly, it will look at the class level. Maksudnya, it will assume that the class level is belong to the one class level. But the reality, the data does not belong to one class level. So we have to look at which is the splitting attribute, assuming we choose refund as the best splitting attributes. Alhamdulillah, boleh faham semua? Saya pula yang seronok bercerita, tapi saya harap awak faham.
Faham.
Faham, madam.
Okay, boleh buat Right.
Boleh, insyaAllah boleh.
So you can refer it to the images here lah. Saya tak ya. So that will be the concept of constructing tree by looking at the class level and determining the best attributes as splitting attributes. Look at the value of the attributes and split the data. Split the data. Okay. This will be examples of how make the split. How the algorithm make the split. It's based on the nominal. If it is based on the monomial, we would have multiple ways split, and it could be two ways binary like we have done just now. So the value of the attribute can be combined. It could be can be combined. It can be done by institutions by the by the count probably sometimes. Okay. Also for the ordinal. Okay, I'm not going to look at this one too much. Okay, so now the next questions, you know how to construct the tree. Okay, the next questions would be, the next question would be how to determine the splitting attributes. Macam mana kita nak pilih refund? Kenapa kita tak pilih marital status? So that will be the questions. Yeah, so that will be the questions. Yeah, so when we have lots of attributes, we need to know which one will be the most important attribute ataupun which attributes actually has split the data into the same class level. Okay, for that purpose, actually, there will be a formula to do that. Yeah, so the formula like you see in these slides is known as information gain. Yeah, it's also other measures lah. There are lots of measures, but today we are going to use information gains. And this is also known as to know whether this splitting attributes has partitioned the data into same class level or not. This is what we call as impurity measures. Yeah, whether the attributes has divide same class level means that it's pure to one class. Yeah, kalau ada combine, ada mix tu maksudnya impure lah, ya, tak tulen, ya. Okay, so this will be again we are going to use firstly information of the data set. Yeah, the formula that involved will be firstly is information of data set. Okay, and then we need to know information of the attribute, and lastly we will get the gain of the attributes. Okay, so how then we decide based on this value? We are going to use gain. Yeah, we are going to use gain here. Larger difference, the better test condition, meaning that we will compare gain of each attributes. Okay, the one has produced highest score for gain will be chosen as the splitting attributes, right? So let's see the example. Okay, now we are talking about mathematics. Okay, so this is the first formula. Okay, and the formula is known as expected information of the tuple of the data set. Okay, so the information of data set is actually minus or the signal negative here, summation of probability log to probability of the class level. Okay, so if you have two class levels, means that you would have probability of class level A log 2 probability of class level A plus probability of class level B log 2 probability of class level B. Summation of this and put minus in the beginning. So this is what we call as the entropy. Okay, next the formula will be what we call as the information of the attributes. Okay, so information attributes will be quite complex, but don't worry. Yeah, it's actually replicating the same process like what you see in the previous formula. Okay, and after you get the information of the attributes, you will compare. You will compare the information of the data minus the informations of the attributes. Okay, and then you will check, because this is attribute A, you will have attribute B, attribute C, attribute D, and so forth. So you will see the highest information gains among the attributes will be chosen as the splitting attributes. Okay, understand? Right. Let's do the math. Right. So this will be the first information gain steps. Yeah, this is the first steps for information gain. Okay, how do I get this one? How do I get this one? Matrix, this matrix. Any idea? Okay, very good. So you just refer to the class. Imagine the class level is by completed or not. Okay, so how many belongs to yes, how many belongs to no? So you see the count here. Yeah? So altogether we have 14 records. So 9 is yes and no is 5 records. So how you apply information of the data set is like this. Is you see information 9 is belong to yes, 5 belongs to no, 5 belongs to no. So minus, yeah. Minus, sebab kita dah buka kurungan, so minus 9 divided by 14 log 2, okay, 9 divided by 14, so this is for class label yes, right, and this one is for class label no. Okay, so you are going to use log 2 in your calculator. Any problem? Boleh guna log 2 in calculator? Kena beri practice lah.
Boleh.
Kena practice lah ya. Okay. Right. So this is clear, right? Okay. So this is again information of the data set. Okay. So based on the class. Right. Next one. This is the information of attributes. So how many attributes that we have? Tolak the class label. How many attributes that we have?
4.
Right, good. So we have age, income, student, credit rating. So we have to repeat this step. Step 2 ni, you have to repeat for each of the attributes. Alright, so how to do this? Firstly, look at the first attribute, which is age. So age, how many label? How many values? So it has youth and it has middle and it has senior. Okay, and this is belong to yes and this is belong to no. Okay, you look at the youth 1, 2, 3, 1. You look at youth with no 1, 2, and then youth with no 3. Okay, 3 no for when you age equal to youth. Okay, and then 2 yes when age equal to youth. Understand? Okay, next one is when age equal to middle, okay, we can get 4 count for yes and 0 count for no. Okay, when age equal to senior, we get 3 counts for yes, 3 and also 2 counts for no. Okay, so from here, you will use this formula, yeah, and it's actually this is the first total of age value, which is 5 over 14. 14 is total of the samples. Okay. Meanwhile, for middle, there are 4 samples over 14. And then for senior, you have 5 over 14. Okay. And how about this one? Okay, so this is implementing the previous previous formula, which is minus 2 over 5 log 2, 2 over 5 plus 3 over 5 log 2, 3 over 5. Boleh faham? Okay, how about this one? Can you expand it? Can you expand it? Chana?
4 over 4 log 2. Lepas tu
4 over 4. Yeah. Okay, and then plus lagi?
0 over 4 log 2.
0 over 4 log 2, 0 over 4. Yang belakangnya tinggal So 0 over 4. Okay, and summation dia, dan don't forget the minus sign. Okay, understand? Understand?
Yes.
Boleh
Boleh.
Okay, how about this one? How you expand this one? How you expand this one?
3 over 5 log 2.
Yes, good. 3 over 5. Yeah, plus 2 over 5 log 2, 2 over
2
5.
over 5.
Okay, the summation and put the minus sign. Boleh Right? So after you calculate this, after you calculate it, you will get here 0.694. Okay. Okay, so you need to calculate. Okay, this one is for age. Next, you need to calculate it for. Okay, this is mana lagi satu ya? Saya punya animation tinggal ya. Okay, so you need to calculate pula kepada what we call income, ya, students credit rating, ya. Okay, next katakan this, katakan you already you get everything, ya, done and calculated. So how you get the gain pula, ya? So this is the third step, calculate the gain. So gain is equal to information of the data set minus the information of the attribute. What is the information of data set just now? Yeah, information data set is this one. Yeah, the first one 0.940. Okay, good. Minus 0.694. Okay, and you will get this value. Understand? Okay, and then get the value of income, students, and credit rating. It's been calculated here. Okay, what is the highest gain? Which one is the highest gain?
Student.
So it is the student. Students kecil kan, 0.1 kan. So H is the student. H is the highest. So what we are going to do next? So that H will be chosen as the root node for this case. Okay? Understand? Okay.
Understand.
So you will get H here and then here 1, 2, 3 lah. So you will have use and then you will have middle and then you will have what we call apa nama? Seniors. Okay, and then the algorithm will check if it is belong to yes. Okay, kat sini kena ada another attribute lah. If it is belong to middle tadi, all is belong to one class level kan? Middle tadi semua belong to yes. Betul tak? Okay, but when for senior it has combination. Okay, let's me look back here. See, this is same, but this is multiple. Two class level, and we look at the senior 2 class level. Though H has been chosen because the gain is highest. Alright. So for the next cycle, what do you think? Kat sini kita nak pilih apa pula? So the algorithm will calculate. Okay. So we already calculated H done. Okay, so it will check under this root, under this root, maksudnya under root of youth saja, under root of youth, it will use record this one, and then record this one, okay. So it will using 1, 2, 3, 4, 5 records here, and you based on income, student, credit, which will be best splitting the data set. Okay. Meanwhile, if you look at senior is kejap. Let me change my pointer. Okay, if you look at senior, so medium here, okay, and then we have here, tak nampak here. 1, 2, 3, and then 4 and sini tadi, so sini total here tadi 4, this one is 5 records, and this is will be another records. So it will be repeat like that. Boleh faham tak? Understand?
Boleh faham.
Alright. If you look at the next slide, this is how you calculate for age. This is the age. This is for income, and then this is for students, and then this is for credit rating. You can do this exercise, and this is what I have discussed just now. If you look at under age, middle age just now, all belong to the same class, so that there is ini terbalik pula gambar dia. You imagine, you betulkan lah. So this is a termination node. Okay, if the value is used, yeah, and it has been calculated based on 5 samples just now, and it has choose students as the next attribute. Okay, meanwhile for senior, it chose credit rating is as the best attribute. And at the end, it finished here, yeah, because based on when age equal use and then with the attribute students all belongs to the same class for no, and is also student equal to yes, by computers is equal to yes, yeah. Okay, that is what you could understand from the algorithms. Algorithms were actually looking at the samples and looking at the attributes. Is there any more attributes can be chosen or in the data set? And the main point is that it must be belongs to the same class level. Selagi tak sama class level, dia akan cari splitting attributes and try to divide the ataupun try to partition the data. Okay. So, the next question. Adakah semuanya akan menjadi begitu? What do you think? The next question. Do you think that all data will be like that? Means that every data will be belongs to the same class. What do you think? Hello?
It will differ with every training set, I think.
So it could be sometimes you would not achieve this ideal case. It would not achieve the ideal case. It means that your termination criteria will, keep on looking at, oh, I couldn't, I cannot split the data. I cannot split because it would not achieve. It will not achieve the condition where all samples belongs to one class level. Okay, so for that case, there will be another termination condition which majority. That is another termination condition kan tadi? You tengok majority belongs to the same class level. That's why when you look at the WECA, yesterday I show you one of the parameter is confidence factor, meaning that at least majority 0.25, it achieves 0.2, not less than 0.25 belongs to the same class, 0.75 lah. Kalau dia 0.25 means that 0.75 must be belongs to the same class level, majority. So that is what you see in the WECA. Okay, all right. So if you look at these three, it actually can be transformed into the rule sets. Yeah. So easily for us to understand, the rule extraction can be done from the tree, and this is actually a knowledge base. Yeah. Again, if there is a lot of branch and there's a lot of roots, so branches, then we have to look back to the set of attributes, whether you are going to consider all attributes in your data set. Back again to the process of what we call attribute selects under pre-process. Yeah. Okay, so this will be another illustration of getting the best split. Yeah, is that only information gain? No, there is more other measures can be used. This is gain ratio, Gini index. We could see, in the real fact or research literature, there are chi-square, correlation, and CART just now, regressions, regressions and so forth. So that can be used. So I think with that, that's all for today. Today's session. Any questions so far?
No.
Ada satu question ada.
Ya, boleh.
Kenapa tadi yang marital status tu split jadi 2? Maksudnya single dengan divorce tu dia jadi 1 kan?
Sebab yang itu
okay.
Yang itu kita assume kita buat binary tree tadi.
Oh, so by default dia memang macam yang jadi 3 lah.
Kita boleh choose lah, either you want to go for multi-way ataupun you want to go for binary.
Alright, understood.
Right.
Doktor,
Yes.
Kalau for multi-way punya tree can be more than three ways kan? Depends
Betul.
on the attribute. Okay.
Ya. Betul. Exactly.
Thank you.
Alright. So maksudnya kalau mana-mana data that is being combined means that the count is included lah, ya. When you create what we call contingency table tadi, what is the contingency table ni just now? When we calculate the count, this is contingency table, saya tak sebut ni. This is contingency table lah, ya. So when you create the count means that, for example, you are considering youth and middle in the same, okay, in the same branch kan. So the count become 6 lah rather than 2 and 4, right? So the count become 6. Understand? So you will have like this lah. Okay, so this is your youth middle, and also this is a senior, and this is 6, this is 3, and this is 2, and this is 2. Okay, so you would have rather than 3 lastly, yeah. Ini adalah 3 branches kan. So you might have like this lah, age, and then you have youth and middle, and this is senior. Okay. Alright. Okay, another thing that I want to remind to you is that about next week. Next week you ingat tak?
Lab test.
You check, bagus, alhamdulillah. So you sensitive and then you aware about your lesson plan. So next week is about adalah lab test. Okay. So lab test, I'm going to do the lab test on Selasa lah ya. Selasa during this session, during this session because everybody in. So I'm going to do the test in MS Team, and then please check for the notification MS Team, and masa yang diberi adalah 1 jam setengah. Okay. So 1 jam setengah you nak start pukul berapa? 8 suku boleh?
Boleh.
Ya?
Boleh.
So, suku awal sikit lah. So 8 suku. So you should finish by 9:45. Boleh? Jangan tertidur lepas sahur.
Boleh. Boleh,
Alright.
Doktor.
Okay.
Boleh.
Alright. So what's to cover is topic 1 until pre-process. Yes. Yeah. Topic 1, topic understanding, and also pre-process. Classification for today will not be included. Alright, so don't forget to log your attendance. Hope that you can have a good revision time for next week. Anything that you want to ask, you can always ask me in the group pun, tak ada masalah. Kalau nak WhatsApp pun boleh. Okay, kalau tak ada apa-apa, that's all for today. Thank you for joining the class. Hope that hari ini dan seterusnya baik-baik sahaja.